Okay, hi everyone. Sorry this has been a little late, but here is a couple review questions for the take-home final. Okay, so here's the first problem. You're considering purchasing a CNC machine which costs $150,000. The machine will have an estimated service life of 10 years with a net after-tax salvage value of $15,000. Its annual after-tax operating and maintenance costs are estimated to be $50,000. To expect an 18% rate of return on an investment, what would be the required minimum annual after-tax revenues? Okay, so here's identified my givens: initial purchase, service life, salvage, operating and maintenance, and your rate of return. Here's my sketch. So the blue is your operating and maintenance, the initial investment, the salvage, and then the X here is the revenue. All right, so the revenue is what you're making. So basically that's what we're finding. So what you do is you find the net present worth. Take 150,000 because that's at year 0, and then we just take the red minus the blue, and that's the annual. We want to find the present worth, 18% for 10 years. We can find that fraction on Appendix B, and then do the salvage rate, which is really a future converted back 10 years. And when you do this, you end up getting 82,739. All right. Very similar to one of the homework problems that you had. All right, here's another similar homework problems to find I star and your internal rate of return true with a MARR of 8%. So the first thing you want to notice is actually, if it goes negative, positive, negative, that indicates it's a mixed investment or non-simple. And there's a different way. I star isn't as easy as, well, I star is not the same as your IRR true. So here's our given, 8% for MARR, 2 years. We're finding I star and the true internal rate of return. Here is cash flow. And in order to find I star, and this is the same for simple and non-simple or pure and mixed, basically you find the net present worth. So convert every value back to year 0, set it equal to 0, and solve for I star, basically your break-even point. So basically what we do is we have negative 150,000, then we break back 465,000 back 1 year, then we bring back 330,000 2 years. Now there's two ways you can solve this. You can just loop I from 0 to 110% and then figure out when it equals 0. And we know that it changes from negative to positive twice, so there's going to be 2 answers. Or you can just simply do algebra and assume that x is 1 minus I star. Okay, that's what this red is. And then this is actually x squared, and use the quadratic equation. And your x becomes 0.5 and 0.909, and then just rearrange this green equation for I, and you get 0.1 and 1%. All right, so because this is a mixed investment, you got to, in order to find the true IRR, you got to look at the project balances. So the first case is look at project balance 0. It's negative, so the next year project balance in blue, you're going to use I here. So in order to find the next year's project balance, you take the previous project balance, which is the present, and basically this is a future value, and you add your cash flow. That's why this is always to the 1. All right. Now this next equation I just simplified and then finally got to this. Now there's 2 cases. We don't know if project balance is greater than 0 or less than 0. So if case 1, if I is greater than or equal to 2.1, your project balance is going to be less than or equal to 0. Okay, case 2, when I is less than 2.1, your project balance is positive. Okay, so I just went with this because this one's easier, because when the project balance is positive, in order to find the next project balance right here, and let me fix this. This should be to the power of 1. You take the previous balance and you multiply by 1 plus the interest rate, but because the project balance is positive, we have to use MARR because we've actually borrowed money from a bank at this interest rate. to the 1, and then we subtract, because it's negative, the cash flow. So I substitute what project balance 1 is, multiply by the 1 plus the MARR, and you end up getting this equation here in black. Now, in order to find I, we set it equal to 0, the project balance, because it's kind of like breaking even, and we get 6.3%, which is actually less than 2.1, or 210%. So is case 2 satisfied? You will find that case 1, you have to use a quadratic, and it's longer, and it actually doesn't satisfy. All right, so you've had numerous examples like this, multiple in-class, multiple homework problems. Now the last problem, basically I just want you to determine simple and non-simple. So the first one, because it's negative, negative, positive, positive, it's simple. But over here it's negative, positive, negative, negative. That means it's mixed or non-simple. All right. Now again, if you notice in red, you can find the rate of return of these, but because they're to the third, and you've noticed in the homework that there's actually, when you get the project balance, there's 2 cases, and then under project balance 3, there's 2 more cases for each case. So it's just even longer and longer. And as long as you know how to do project balance the second year, you're fine. Okay, if you have questions, please let me know. Other than that, I look forward to seeing your take-home exam. All right, have a good night.